In lesson 1.3, you're going to be graphing linear functions that come in various forms. Then we're going to be writing equations of linear functions given certain conditions. We're also going to look at perpendicular and parallel lines, their slopes, writing equations, given conditions involving those as well. So the first thing let's look at are the different forms of linear equations. As you'll recall from Algebra 1, slope-intercept form of a linear equation is y equals mx plus b. And m, the coefficient in front of x, is your slope. It's only the coefficient though. A lot of times students want to say 4x is the slope. No, in that case 4 would be the slope. So make sure you don't take into account x when you list slope. B is your y-intercept, and of course that's always written in ordered pair form. So if I'm asking you what is the y-intercept and you see plus 2 at the end, then you will say ordered pair 0, 2. Math Excel also wants you to list those as ordered pairs. Second type of form of linear equation is called standard form. It is ax plus by equals c, where a is always greater than or equal to 0. If for some reason you encounter an equation where a is negative, then divide through by the negative sign. You always want a, the coefficient in front of x, to be greater than or equal to 0. A, b, and c, you would also like for them to be integers ideally, but sometimes a and b can be fractions. The third type is called point slope form. You always use this equation or form to write equations of other lines. So point slope form, it involves a y and a y1. Y minus y1 equals m times x minus x1. Later on you're going to see we're going to plug in an ordered pair for the x1 and y1, leave this x and y, plug in a slope for m, and write our other equations. We're also going to be graphing lines in slope-intercept form, graphing lines in standard form. I'm going to show you a shortcut for finding the slope when your equation is written in this form later on, as well as show you a shortcut to graph those. Okay, how you determine if an equation is linear versus quadratic, cubic, quartic, and so on is you look at the degree of x. And degree just simply means your exponent, or your highest exponent of your variable. So for example, linear means that my degree of x has to be 0 or 1, and we're only concerned about x. In this equation, you have y equals 2x plus 3, which is in slope-intercept form. Your exponent of x, which is invisible, is understood to be 1. This equation is written in standard form, ax plus by equals c. Your exponent of x is also understood to be 1. And this is actually a horizontal line, y equals negative 5. X equals negative 2 is a vertical line. They're still linear equations. They form a line. You don't even have an x variable in this type of equation. And you do here, and x exponent is 1. Horizontal line, vertical line, always linear. Slope-intercept, standard form, always linear. Non-linear types are degree, where nonlinear is where the degree of x is not 0 or 1. So if you look in this case, xy equals 3. If you solve that for y, you're going to get 3 divided by x And if you'll recall from exponent rules, 3 divided by x is also equivalent to 3x negative 1. Remember, you can take a variable and flip it to the numerator or denominator as long as you change the sign of its exponent. So for example, really quick, if I have 4 over x squared, that's also equivalent to 4x to the negative 2. That's side lesson on exponents. Okay, the next examples that are nonlinear, which is what I was showing you here in those steps, is a quadratic. Notice when the exponent of x is 2, that's a quadratic, and its graph will be a parabola. The highest exponent, notice that I do have an x here, but its exponent is 1. This exponent is 3, meaning it is cubic. And this exponent of x, since it's square root, this is also equal to x to the 1/2. It's power over root. So as you're seeing, if x is in the exponent area, it is definitely nonlinear. This would actually be an exponential graph. So linear just means that they all form lines. If they curve at all, it's definitely non-linear. All right, the next type of lines that we're going to talk about is perpendicular lines and parallel lines. Perpendicular lines always intersect at 90-degree angles. So I'll give you an example using this slope. Let's say I've got a line and its slope is negative 1/3. And let's say that we start at the origin. So it's going to go down 1, to the right 1, 2, 3. And then you can reverse that and go up 1, and to the left 1, 2, 3. So that's what this line would look like. It should intersect, which I've done a rough sketch, it should intersect at 90-degree angles. This graph, let's say I also start at the origin, and I'm going to go up 3, 1, 2, 3, and to the right 1. Going to go down 1, 2, 3, to the left 1 to reverse it. So notice that it does appear that they are intersecting at 90-degree angles. Their slopes are negative, meaning that the sign is changed, reciprocals of each other. So change the sign and flip, change, flip, change, flip, change the sign, flip, change, flip. Parallel lines are easy because, of course, they have the same slope. Say I graph a line here that has a slope of negative 1. And then I graph another line that also has the same slope of negative 1. So right 1, down 1, or up 1, left 1. So parallel lines have the same slope, perpendicular lines, negative reciprocal slopes. Okay, before we actually start writing equations of lines, I need to go over and review with you how to graph in slope-intercept form and standard form. That's when you have y equals mx plus b. And the first thing that you want to do is plot your y-intercept, which is always 0b. Plot your y-intercept. If you don't have a value there, then your y-intercept is 0, meaning that your line will pass through the origin. Step number 2 is use slope, m, to graph a few other points. To graph some more points. And then, of course, just connect them to form your line. So we're looking at, we'll graph 2 really quickly. Part A, y is 3/4 x plus 2. Part B, y equals negative 1/2 x plus 1/2. All right, so in part A, let's first plot our y-intercept of 2. And in this case, like if you know your y-intercept small, such as 2, 1/2, I mean, I would say just draw your graph out to about 5 or 6 places, which of course you can find free graph paper online and print some out if you have a printer at home. So the first thing I'm going to do is plot my y-intercept of 0, 2 on the y-axis. And then I'm going to use my slope, which is positive 3/4. So your line's going uphill. To go, and we'll go in both directions. We'll find some points on this side. We'll find some points on that side. So let's go up, 1, 2, 3, and to the right, 1, 2, 3, 4. Remember, rise over run. And then rise means you go up or down first, then you go left or right. So then we're going to go down 1, 2, 3, to left 1, 2, 3, 4. And of course, you just draw your line through those points. Easy enough. Hopefully you do remember that from Algebra 1. And part B, same thing. All right, first thing, plot your y-intercept of 1/2 here. Then I'm going to use my slope, which is negative 1/2. So we're actually going to go down 1 and to the right 1, 2. And let's go up 1 and to the right 1, 2. And then of course just connect your line through those. Okay, the next step, which I don't know if you've ever seen the second part before, is actually graphing in standard form. Standard form, recall, is your lovely AX plus BY equals C graph. And you're going to love this. I'm sure in the past you've been made to solve this for y and put it in slope-intercept form, but you don't have to do that in this case. So what we're going to do here, the first thing we're going to do, and you're going to be asked to do this in your Math Excel. So step 1 and 2 combined, you're going to find your x and your y intercepts. It's really easy to do that. You do have to make sure of, all right, well, find your x and y intercepts, make sure your x and y terms, your x and y, are on the same side of the equal sign or the equation. So make sure x and y are on the same side, and they are in this case. All numbers are constants, and that's what C stands for, are on the other side. So make sure your x and y terms are on the same side, and all numbers are on the other side combined. Okay, so here's how you find your x-intercept. So finding the x-intercept, this is what you do. You take your x term and set it equal to whatever C is. So take your x term and set it equal. So I'm going to take AX, that whole chunk, and set it equal to C, and you're going to solve it for X. You're going to be able to do this in your head. You're going to be able to look at it in a minute, you'll see, and say, okay, well, if I take away what BY is, and I'll solve just this equation I have left for X, that's your x-intercept. And we'll put that point on the x-axis. Second part, find your y-intercept. You take your y term, paying attention to sign, and you set it equal to C. So you're going to take BY and set it equal to C, and you're going to solve that for y. And put that point on the y-axis and draw your line through those points. Be careful with sign for that. Like if that's a minus sign, you want to take that into consideration. Okay, let's see what that looks like. Okay, number 1, or 2 rather. Graph using intercepts, or they may just tell you to graph it, and they might not tell you to use intercepts. In part A, let's say that I have 4x plus 2y is equal to 8. In part B, I have 1/2 x minus 1/4 y is equal to 3. In part A, I want to find my x-intercept. So find my x-intercept, I'm going to take 4x. Pretty much the y goes away. The y term goes completely away. Take your x term, which is positive 4x, and you set it equal to 8. Make sure, once again, that x and y are on the same side and all numbers are on the other side. And they are. So 4x equals 8. And then divide both sides by 4, so you get x is 2. Y-intercept, I take positive 2y, and I set that equal to 8, divide by 2, y is 4. So there's your y-intercept. which of course in ordered pair form this would be 2, 0, and in ordered pair form this would be 0, 4. Sketch a graph. Make sure that your y-axis goes up to at least 4. And then make sure your x-axis goes out enough spaces for you to plot 2, which definitely won't be hard. And then we're going to plot our x-intercept, which is 2. Plot our y-intercept, 4. And just connect your line through those. And voila, you've graphed quickly. I didn't have to solve that for y, put it in slope-intercept, then use slope-intercept form to graph it. Take your x term, set it equal to that, solve that little equation, set y equal to that, solve little equation. This will be your y-intercept, put that point on the y-axis. This is your x, put that point on the x, plot your line. Part B. Let's find our x-intercept. Set your, first of all, once again, make sure that your x and y are on the same side and all numbers are on the other side. So that's the case, so we're good to go. Set your x term, 1/2 x equal to 3. When you solve this for x, to get rid of 1/2, you actually multiply by 2. So you end up with x equals 6. Solve for your y, take your y term and set it equal to c, which is 3. To get rid of negative 1/4, we actually multiply by a negative 4. And when you do that, you're left with positive y equals negative 12. Since your y-intercept is large, you can of course scale your y-axis. For example, you can go by 2s if you want to. I think that's what I'm going to do. So this will be 2. And I'll just go by 1s on the x. So your x-intercept was 6. Y-intercept is negative 12. And then plot or draw your line through your points. Okay, so that's how you graph in standard form using the intercepts. Okay, the next thing that we're going to talk about really quick is finding slope, and then we can move on to writing equations. Okay, if you find slope from a graph, of course, you just simply count your rise over your run. Second way you can find slope is between two ordered pairs x1, x1, y1, and then x2, y2 by using the slope formula. Y2 minus y1, please make sure you always put your vertical displacement on top, y2 minus y1, and your horizontal displacement on bottom. Just simply means make sure you subtract your y's on top, make sure you subtract your x's on bottom. Another way to find slope is from looking at when your equation is given to you in slope-intercept form. So of course your slope is always m. This is probably new to you. I don't know if anybody's ever showed you this shortcut for finding your slope when your equation is in standard form. Because normally you've been made to solve that for y, put it in slope-intercept. But, very important, your slope, when you're given a standard form equation, is to take the opposite of a and put it over b. Take the opposite of the number in front of x, put it over b. So slope in standard form is negative a over b, the opposite of a over b. So if this was negative, then a would become positive when you plug in, and you would do the positive of b. So if there's a minus sign in front of b, you consider that. But always do the opposite of a, and b stays the same. And of course, already recall we've looked at how to find slope of parallel lines and perpendicular lines. Okay, next step. Is writing equations of lines. You always, in order to write an equation of a line, you always need a point, an ordered pair that will be on that line, and you always need the slope of it. You may have to do some work in order to find either or both of those components, as you're going to see in a minute. Always determine the slope that you're given. For example, if they give you a slope and then they ask you to find the equation of a line perpendicular to this line that you're given, you always want to use the slope that you're given. You need to figure out if you need a new slope or if you can use the one that you have or the one that you found. You take your new slope and your ordered pair that's on your line and you plug in to this formula. Recall that this is point slope. So once again, find a point on the line that you're trying to write the equation for, find its slope, plug in, and pay attention to your direction. Sometimes they'll ask you to leave it in point slope, which actually makes it really easy for you because you just have to plug in your ordered pair for x1 and y1, plug in your slope, and leave it. But if they ask you to leave it in slope-intercept form, then you got to simplify and solve for y. If they ask you to leave it in standard form, you have to make sure x and y are on the same side and everything else on the other. Okay, so we're going to write our answers in standard form or slope-intercept form. And usually if you're leaving it in standard form, you want a, b, and c to be integers or whole numbers and a to be greater than or equal to 0, but it's okay. I'm going to show you that's ideal, but we're not going to strive for that. All right, we're going to go through this, the last part of this lesson. We're going to write equations of lines given certain conditions. Okay, number 3. Your particular conditions that you're given in this, you want to write the equation of a line that contains the order pairs, -1, 6, and 3, negative 2. So going back through your steps, here you need to make sure that you have a point and a slope to plug into point and slope form. So ask yourself, do I have a point? And yes, they actually give you 2. Yes, you have 2 to pick from. You can choose either one. And then the second thing, do you have a slope? And you definitely do not see m equals, and you definitely don't see a slope. So for this case, we have to do some work to find the slope. Then you have to also think to yourself, well, how do I find the slope based on what you're given? Well, you're given 2 ordered pairs here. So of course, finding the slope, if you're given 2 ordered pairs, it's number 2. You have to use the slope formula. So number 1, find the slope since you're not given that. And we're going to use, this is x1, I'm going to use that's y1, x2, y2. So m equals y2 minus y1 over x2 minus x1. If you will label your ordered pairs as such, it will be easy, a little bit easier anyway when you plug in. So y2, remember y is always going top, y2 is negative 2 minus, that minus sign's built in, 6, when that creates negative 8. x2, which is 3, minus x1, which is negative 1, and that makes positive 1, so that becomes 4. And simplify this further if it will. Negative 8 divided by 4 becomes negative 2. So there's my slope that I need to use later on. Okay, since we already have a point, then my next step is going to be take a point and your slope of negative 2, plug in for the x1 and the y1 and m in y minus y1 equals m times x minus x1. All right, pick either ordered pair that you want to use. You can use negative 1, 6 or this one. I'm going to use negative 1, 6. And of course we know that our slope is negative 2. So let's go through and plug in y minus, when you plug in, this is your y1, and then remember your slope was negative 2. Plug in your x1 of 6, x1 of negative 1. Okay, from here, if they were asking you, I'm going to show you what it will look like if you left it in point slope form, slope intercept, and standard form. So pay close attention to your directions in your assignment. We always clean this up inside. So y minus 6 equals negative 2 times x plus 1. This is what it would look like if you left it in point slope. You don't have to distribute. Just clean up inside if you need to. So that's point slope. However, if they ask you to go further and leave it in slope-intercept form, you would actually have to solve it for y. So this is what it would look like. You would take your equation from above and distribute -2, -2x minus 2, and slope-intercept is y equals mx plus b. So you want to make sure that you solve it for y and your x term is on the other side. So the only other step we have to do is simply to add 6 to both sides. So if I add 6, I'm going to get positive 4. So in slope-intercept, it would be y equals -2x plus 4. If they ask you to leave it in standard form, it's ax plus by equals c. So since we've already left it in slope-intercept, remember for standard form, just make sure your x term and y term are on the same side, all constants on the other side. So you would take this and simply move 2x to the left side, so it would become positive, and that is in standard form. So just pay attention to your actions. I'm sure you'll love it if they ask you to leave it in point slope form because you're done at this point. But slope-intercept, solve for y, x term has to be on the other side. Standard form, x and y terms on one side, constants on the other. All right, this is number 4. Write an equation of the line given certain conditions. This line contains point 2, -3, and is parallel. That's the symbol for parallel. Hopefully you remember that from geometry. It's parallel to y equals -2x plus 7. You need a point and a slope. You have your point, and you use the line it's parallel to obtain your slope that you need to use. Recall that parallel slopes are the same. Your slope that you were given here is -2. Since it's parallel, you're going to use the same slope, but be careful if it was perpendicular, you would need to flip and change sign. So use the same slope. Let's go through and plug in. So take your point of 2, -3, slope -2, plug into your point slope formula. Going to plug in your point. This is your y1. This is your x1. Plug in slope for m. And then go through and simplify. So y plus 3 equals -2 times x minus 2. That's in point slope. If we go ahead and solve it for y, distribute -2, and then subtract 3, -2x plus 1, that would be in slope intercept. If you move the x term to the left side with y, then this would be in standard. Once again, you don't have to do all three forms. See what your directions ask. So that would be in standard, slope intercept, or in point slope. Number 5. Your line contains 3, 5 and is perpendicular to 2x minus 3y equals 2. So my line is going to pass through this point, but it's going to be perpendicular to the line whose equation is 2x minus 3y equals 2. So we have my point. Your slope that you're given, remember your trick or shortcut is negative a over b when it's in standard form. So do the opposite of the number in front of x, so negative 2. The number in front of y is negative 3. So it's always the opposite of number in front of x. Number in front of y stays the same. Negative negative makes a positive 2/3. But you need to be very careful. Am I going to use this slope, or do I need to flip and change? You're going to use 3, 5. And then you need a slope that is perpendicular to this one. So my slope that I'm using, I'm going to flip that 3 halves, and I'm going to make it negative. So as long as you remember, flip and change that. So let's plug into my point slope form. So y minus 5 and then you got negative 3 halves x minus x1. This would be your answer in point slope, but most of the time they're going to ask you to keep going and change it to slope intercept. So we will need to distribute negative 3 halves. Please be careful when you're multiplying negative 3 halves to 3. Remember, when you're multiplying fractions, you multiply the numbers on top together and the numbers on bottom, and any whole number has 1 in its denominator. Negative, negative, positive. Then I'm going to add 5. So I would get negative 3 halves x plus 9 halves plus 5. You need to simplify that, so let's find the common denominator. This will turn into 10 over 2. So then 9 halves plus 10 halves makes 19 halves. So that is your equation in slope intercept. You could actually go through and get rid of fractions here if you wanted to, and I'll show you how. Remember, if you go through and multiply by the denominator, notice that your denominators are 2. So go through and multiply everything by 2, and that will give you 2y minus 10 equals negative 3x plus 9. then you would add 10, and you would get 19. And then you would divide through by 2, so you get negative 3/2 x plus 19 over 2. So either method, if you want to work with the fractions, that's fine, or if you want to clear them, that's fine. But this would be your answer in slope-intercept. And then, of course, to get it in standard form, you would add 3x to the side y is on, and you would have this. Okay, one more equation I'm going to show you. Well, two more things. You're going to see this in your homework. All right, really quick, last thing. All right, if I know that my line contains 0.32 and that my line is also parallel to the y-axis, I want you to think about what type of line that is. So, of course, you've got your y-axis here. A line that's parallel to that, of course, would be another vertical line. And you recall a vertical line's equation is always x equals a constant, or x equals some number. And all you have to do, there's no work for these problems. If you're asked for, or if you're given a point and it says it's parallel to the y-axis or parallel to the x-axis, then look at your x-coordinate. X equals 3 would be your line. Because I've got an order pair at 3, 2. And if that line's parallel to the y-axis, then it's going to be x equals 3. Same thing, if I have line 3, 2, and I'm told that it's parallel to the x-axis, then I've got the same order pair, 3, 2. But in this case, my line would be parallel to the x-axis. So your equation would be y equals 2, your y-coordinate. Okay, on number 16 in your homework, they give you a pair of points, 1y and negative 4, 5, and they tell you that the slope between these points is 2, negative 2. They want you to find the value of y that would make this true. Recall the slope formula between 2 points is y2 minus y1 over x2 minus x1. So just take your points and plug in. You've got y2, which is 5, minus y1, which is y, that's what we're trying to find, equals negative 4 minus 1 on the bottom. But I do know that my slope is -2. So let's take this. I'm going to go ahead and say that's -5 on the bottom, and I'm going to set this equal to -2. Then multiply 5 minus y equals +10. Subtract 5 from both sides, divide by the negative, so y would be -5. Of course, you can go back and double check your work and use the slope formula on the ordered pairs and see if you get -2.